Well, we have talked a lot about the Burj Khalifa in Dubai, the new tallest building in the world over the last several years. We've talked about the building, but we haven't talked very much about construction, and that's what we're going to do with Mr. KJ Kim, who is with Samsung Construction and Technology, and he is the project director for the Burj Dubai, the Burj Khalifa Tower project. Welcome to Chicago. You have had the distinction of working on all of the tallest buildings in the world since the Petronas Towers. You worked on the Petronas Towers, and the next title holder was the Taipei 101, and you worked on that one as well. And you also worked on the Burj Khalifa. What kind of experience has that been for you in the last dozen years or so?
Yeah, really this, personally, it was the good opportunity, and also at the same time, it's a kind of honor to be the construction specialist for the, especially for the tall buildings. My experience started from the Petronas Tower, and nearly this, we complete successfully this project. After that, we made a special team who can study these tall building constructions. So last 15 years, we continue to develop the construction method for the tall buildings. So that's why we were able to get this Burj Khalifa project. And we spent 1 year to develop the planning. That was 2004. And then February 2005, we start the constructions. And as soon as we start the construction, our plan was very well organized. So immediately we mobilized the specialists to meet the construction time frames. So that time, this 47 months was the construction period. So to meet this requirement, we have to develop new construction method, like the one floor, we have to finish within 3 days. So that means every 1 day, building is growing like the 1.5 meters per day. And also we have to use the specially customized construction equipment, like heavy-duty tower cranes, and also to meet the logistical requirement, we developed this new hoist to lift the material, and also same time to allocate the manpower to the designated area. So that kind of construction method was developed especially for the Burj Khalifa. And also we developed new construction survey method because of this building goes high and there is a lot of construction dust. We cannot use the traditional surveying method to keep the verticalities. That's why we developed the new GPS systems. But originally this GPS system has the tolerance, and we cannot use this GPS as it is for the constructions because of this tolerance is too much. So we have to control this verticality whole throughout the building within 25 millimeters. So finally we developed this new construction survey method with the equipment supplier. So we are able to manage these verticalities. And the other one is the above level 160. The structure is the all structural steel, and we have to install this spire and pinnacle safely above the 600-meter heights. So we developed this new construction method to meet this requirement by using the hydro jacks, and also this pinnacle was welded on site above the level 160. And we are able to keep this verticality within 20 millimeters. So when we jack up this pinnacle, there was no single problem with the constructions. So last year, January 17th, we are able to reach the top of the tower.
You're probably one of the only construction managers in the world, perhaps the only one. You have made 2 big leaps in your career, because before the Petronas Towers went up, you told me that the tallest building you worked on was maybe 50 floors. And so the Petronas Towers was a huge leap from the work that you'd done before, and the Burj Khalifa even more so. What's that adjustment like, making that adjustment?
Really, the people simply think 150-story building is the stack the 50-story building triple times. But actual construction is not that simple. Because of this, from the design is different. Because of this design, the building structure must be very solid and rigid against the wind and also against the earthquakes. So when we build the structure, we have to consider all this structural engineering in mind. And we have to develop this construction method to meet these technical requirements. So not from the engineering side, the actual execution side, you have to think about all the movement. During the construction, you have this a lot of manpower. They have to move up and down throughout the towers. And for example, this Burj Khalifa, peak time, we had 14,000 workers every day. These people, they have to move like a soldier to the high level. And also this material, during the night, we have to manage this material delivered to the designated floors. So always you have to think about this kind of the combination and also detail management in advance. Otherwise, always there is a problem with the logistics.
Was it much different than the Petronas Towers, or was the Burj Khalifa much more concentrated logistically?
Yes. First, the Petronas Tower was the 92 floors, and Burj Khalifa is the almost double, more than doubles. And the building usage of this Petronas Tower is the office tower. So that means the floor plan is more simple, but the Burj Khalifa is the mixed-use building. So low level was the hotel, and mid zone is the apartment, residence, and the higher portion of the tower is the office. So we have to deliver all the required finishing material to the high levels. So simply this one gypsum board, if you stack together, is taller than a tower. So you can imagine this what's the volume of material to be used inside the towers.
Your boss came to you one day and said, KJ, we want you to build a 162-story building. And I think that everybody, when they saw the drawings of the Burj Khalifa, the Burj Dubai at first, this really set the construction world on its ear. What was your first reaction when you saw this building?
Nearly when I look at this design, immediately I try to figure out from my past experience what is the difficult issue, what is going to be the technical problems. So immediately we can made a plan A and B to meet the design requirements. So
there was, I believe, from the beginning of construction, during construction, the plans for the building changed, did they not? In that it was kind of like hitting a moving target. The building was being revised and it was going to be taller. Is that true? What was it like dealing with that?
Yeah, actually, when we signed the contract, the building height was just above 700 meters. But there was the contractual requirement to meet the building height changes. So the requirement was we have to consider all the logistic and construction method and the equipment for another 200 meter additional. So basically the foundation design was already considered that. and building structure also consider that changes. So we have that kind of the provisional plan to accept the building height changes. So there was a series of meetings to decide what is going to be the final building heights. First, that was the 2005 and 2006. And also this, if you look at the tower elevation, building goes up, then elevation is the smaller and smaller, and there is no working space. So we have to think about how can we build this higher portion of the towers. So that was the major discussion with the designer and also client, how to build the tower higher than the original design.
When they changed the height of the building, were there floors added, or was the spire made taller, or how were the height changes accommodated in the building?
You know, basically the few more building pro added, but basically this increased the spire portion, and also they increased the pinnacles, the height. So
most of the changes were at the top of the building?
Yes, top of the buildings.
You said that there was very little floor space or very little working room in the upper reaches of the tower, the upper floors of the tower, and really nowhere to work. How did you work around the construction method? How did you design the construction method to get that build?
Really, this when we work at the high level, the first priority was the safety, and we have to lift up this steel beam and steel column piece by piece to the 700, 800 meter heights. So we have to be careful with this lifting. So we cannot lift the material during the high-speed wind. So there was a lot of restrictions. And also we have to provide very safe access to the top area. And also we have to provide the safety screen. Can you imagine if we dropped one bolt, go down to 700 meters, and that impact will be huge. So we had a safety protections, double and triple times, and that was our most safety risk area.
How big are some of those floors at the top? How much room are we talking about?
The top area, just below the pinnacles, is the smaller than these rooms.
One of the things I noticed about the construction of the Burj Khalifa, one of the main features of the building at the time were the cranes on the top, and I believe that there were 2 sets of cranes up there. They were lit up at night, and really that's your elevator to the top. That's the way that you get everything up there. Tell me about those crane operators and the job they had.
Oh, this from the low level we had 3 tower cranes, and this crane goes up to the level 160. Then we dropped 1 tower cranes, and we used the 2 tower crane for the spire installations. And then this tower crane operator, they never changed our tower crane operators, and they because of this building height goals, and they must be familiar with the circumstances, and also they must familiar with the equipment itself and with the wind, so they can control these liftings. So that's why these tower crane operators, from day one till last moment, we never changed these tower crane operators, and they have done a great job.
What did you learn from the Petronas towers going forward? What lessons were applied to Burj Khalifa, and what lessons did you get from Burj Khalifa that will go on to the next project?
I believe this, whenever you finish the project, and you can learn a lot of things. and technically and management-wise. And from this Burj Khalifa, really we have used the most developed the construction method and construction materials, and also construction equipment, and also the project management systems. So all these proven the technical and engineering and construction method will be the strong base for the future challenges. So I believe this, the even design side, they can design more higher than these buildings.
Tell me about Korea, because South Korea, there have been a number of super tall projects there, and I assume when those finally start being built that Samsung is going to be right there in construction. What's going on in South Korea right now in terms of getting some of these super talls built? Are we going to start seeing them pretty soon?
At this moment, as I remember this, there's more than six tall building project is under designing. And I believe this within next 2 years, two, three building will start. And as far as Samsung concerned, we are involved in 2 projects. And one project already start the foundations, but for the building usages, at this moment, this design change is ongoing. So we are expecting this tall building very soon in Korea.
And we're talking on the order of what kind of height?
It's more than 600 meters.
So we are going to start seeing super tall buildings in Korea here, hopefully within the next few years. I want to thank you for dropping by and seeing us. Mr. KJ Kim, who's with Samsung Construction and Technology here at the Council on Tall Buildings and Urban Habitat 2010 Awards in Chicago.